A lot of times we probably actually go along the lines of calling these patterns. And part of this that doesn't make sense would be this. Oh, I guess we have to do that. For example, if you have this 3, 6, 9, 12, dot, dot, dot. This is what we call a sequence. It's really a pattern. And a couple things you have to understand about this is that these things that make up the sequence are called terms. And they're just like numbered in order. For example, the 3 is the first term of the sequence, the 6 is the second term, and the 9 is the third term, and the 12 is the fourth term, and it goes on and so on and on and on and on. And a lot of times, they will actually make this look like in table form, so they will, do this sort of thing here, where this is the term, and that is whatever the number of the term. So, for example, if I would ask you what is the 6th term of that sequence, you would probably tell me the 6th term of that sequence is, Alex?
18.
Yeah, probably 18. That is probably it. And along with that, here is the deal. There are 2 types of sequences that the book will talk about. One of them, I just have to look up the spelling of this because it just sounds good, is arithmetic. There's an arithmetic sequence, arithmetic, and there is a geometric type of sequence. Geometric type of sequence. And that, here is the difference betwixt the two. If it's an arithmetic sequence, there is what we call a constant difference between terms. Just put the term. Did I actually write between terms, or do you? I think the term should be a word. Between terms. In other words, this is an arithmetic one because, by the way, the difference we always think of adding, or we always think of subtracting, but it could be adding here. To go from one term to another, what are you doing every time? You're adding 3, correct?
Yes.
So the difference between each term is 3. That really is it. So the constant, is adding 3 every time. Now, a geometric one looks like this, and let me give you a whole different table here so we can look at it. Here's my, let's go first, second, third, fourth term, and then let's put these numbers in here. 2, 4, 8, and 16. Why that's not 8. 2, 4, 8, and 16. And these, ladies and gentlemen, if it's geometric, it has what we call a constant ratio, or AKA you are multiplying or dividing between terms. And if you look at this, children, what am I doing? I can't, first of all, you always look for the addition pattern. Okay, to go from this one, you add 2, right? But to go from 4 to 8, you don't add 2, so it can't be adding 2. That can't be your pattern here. All right, to go from 2 to 4, then after you do addition, you kind of like multiplication or division. What do you do to 2 to get 4? You multiply by 2. What do you do to 4 to get 8? You multiply by 2. So you get from 8 to 16, you multiply by 2. So your constant ratio is multiplying by 2. Okay. You could, your ratio could be a fraction. I could multiply by half, which would be the same thing as dividing by 2. I could multiply by 2/3. That gets a little goofy, but you could do it depending on what your number is there. And you have to kind of look at that and see. And here is, well, they're going to ask you at times to write the formula. This is where it gets a little dicey. Let me do this one. Well, which one do you want to do? Well, let's just pick one. Let me do this. Here's first term, second term, third term, fourth term, fifth term. And let's go this. 3, 9, 27, 81, 243. My little box here. You're mesmerized as always with math class, so you just encourage me to go farther here. Here, when you're asked to write a formula that describes sequences, we usually use these numbers. We use the letter A and we use the letter N. Okay. The letter N is always the number of the term. Okay, and the letter A is the number you want, or the term you want. In other words, this. If I just gave this to you, and use, because A can be any of these, okay, N is the number of the term, A is what the answer you get. We do something like this. A to the subscript 3. This might be the first time we've used subscripts. Please understand, subscripts have nothing to do with multiplying by 3 or using the 3 in any mathematical way. Anytime you use a subscript with math, it is just a label, okay? I am just looking for the third term of A. Okay, so you look at A, the answer to this right there is just 27. That 3 had nothing to do with anything other than a label. It was the third term. Okay, A to the 5th was 243. Okay, the 5 is nothing more than pointing you to the place where you should go. It's not. I'm not multiplying anything by 5, dividing anything by 5. Unlike superscripts, which we call what? Exponents and powers. Those are mathematical. You're going to do something with that exponent 3, 2 times 2 times 2. Subscripts, you'll only see them with letters. Okay, and they're nothing more than a label. They're not something you do mathematically. Okay, so if I were asking you what formula could I use to solve something like this? Okay, in other words, what do you do to N? How can I find, if I wanted to find what the 8th term was, rather than you sitting there doing the math out, or doing the counting by, doing the 6th term, the 7th term, the 8th term, what formula could you use? What am I doing to N every time to get the letter A? Okay, and the way they'll ask you this, and like I said, this is why it gets a little dicey, kids. So if you don't get this, don't worry, most people don't. Okay, if I ask you this, A to the nth term, whatever term I want to be able to figure out what do I do to the letter A to get any term. For example, let's put one in that we know. Okay, A to the first term was what? 3, correct? So what do I do to the letter N to get 3? How can I use this to get something that'll get me that number 3? What would I do to get 3? Anybody? Well, you could say I'm going to take, I'm working with the number 1. What can I do to 1 to get 3? you could multiply by 3, correct? But I ask you, does that work for the second term? If I look at a to 2, do I take 2 and multiply that by 3 to get 9? No, so that doesn't work. Think about this, people. If it's a geometric sequence, it's going to have exponents and powers in it. Okay? If it's a geometric sequence, it's going to have an exponent or a power in it. In other words, what is 9? 9 is what? 3 times 3, right? What is 27? 3 times 3 times 3, correct? What is 81? 3 times 3 times 3 times 3. And what do you notice about this and this, or this and this, or this and this? Caleb?
The top number would be like an exponent.
Exactly. The top number is actually the exponent of what's your base number. What base number are I using every time? 3. So how would I show that in a formula? Okay, you would say it like this. A sub n, a to any term, is going to equal, my base number is 3. And then what do I have to put there? My exponent number is going to be the letter n. Because notice this first one was 3 to the first power is 3. 3 to the second power is 9. 3 to the third power is 27. So you have to get that. Anytime it is a geometric one, anytime you go from one term to the next term by multiplying, it is going to be something with an exponent. If it's the other way around and it's an arithmetic one, you know, let's say it is, here's my first, second, third, and fourth terms, and it goes from 6, 8, 10, and 12, and I asked you to write the formula for that, that should be pretty simple. If it's one of those, what am I going to do? Anybody? My formula using A's and N's the same way. This is my letter N, this is my letter A. A to the first term. Somebody give me how do I go from 1 to 6? What can I do to 1 to 6? I could take N and do what to it to get 6? Multiply by 6. Cabran says. Does that work with A sub 2? Do I take the second term and multiply by 6? No, so I can't multiply by 6, although, people, this is multiplication in some way, shape, or form. What am I increasing by every time? 2. It's plus 2, plus 2, plus 2, right? If it's an arithmetic one, it is multiplication, but you have to figure out how you're going to start. Okay? Times 2, if I multiply 1 by 2, how much am I short? 1 times 2 is 2. To get the 6 from 2, you have to. Does that work for the rest? A sub n, if I take 2 and multiply n by it and add 4 to it, does that work for everything? Is 2 times 2 4, plus 4 is 2 times 3 is plus 4.
10.
Okay, so if it's by adding, if it's an arithmetic one, you have to think n is going to get multiplied by something. So geometric is exponents and powers. Arithmetic is multiplication. Let me give you one because I can tell right now you are completely baffled, puzzled, and whatever. I want to find them here. They don't ask you a lot of these, so like I said, if you're not, then I should really try to mess you up. All right, how about this one? 1, 5, 9, 13. 1, 5, 9, 13. If you were asked to write the formula, this is the first thing I do. This is the pattern, but you always want to add a top line to it. This is your letter A, you need to put your letter N in there. And this is the first term, second term, third term, fourth term. So here's my little table that I gotta try to figure out what's what with. Okay, so the next thing you figure out, is this geometric, is this arithmetic? What are you doing between each thing? Is it adding or subtracting, or is it multiplying and dividing? To go from 1 to 5, you add 4. To go from 5 to 9, you add 4. To go to 9, 13, you add 4. So right away, children, listen to me now and hear me later. There's going to be 4 multiplication. 4 times n is going to be in your equation, because there's no other. When it's an arithmetic one, it has to be multiplication. So when you write down the formula, okay, let's do the first one here. Okay, n, or a to the first power. Okay, I know I'm going to multiply n times 4 to figure this out here. But if I multiply n times 4, do I get 1? But so then what do I have to do with, my answer would be 4. What do I do with 4 to get 1, David? Subtract 3. Does that work for all of them? If I do the second term, a to the second term, 4 times 2 minus 3, does that give me this? Yeah. If I do that to the third term, 4 times 2 is, wait, no, I'm sorry, what am I doing? 3, wait, what am I? 4 times 3 is 12 minus 3 is 9. Yeah, got that there. So you just have to keep that in mind. If it's an adding, it's going to be multiplying. If it is multiplying, it's going to be powers. Feels very good about that. And then there's some that don't feel good. All right, and then they'll give you this. So here you go. Here's an equation. A to the n equals 2n. And they ask you to give the first 4 terms of this sequence. What do you suppose you're going to do? Well, you are just going to start off with a little box here. You're asked to give the first 4 terms, so you write 1, 2, 3, 4, and then you just take this letter n and put it in for that letter n there. What is 2 times 1? 2. What is 2 times 2? Because you just substitute this in for n every time. 2 times 3, and 2 times 4 is 8. So the first 4 terms would be these. And one more, how about this one? A to the n equals, what if it was 2n minus 6? And you're asked to give the first 4 terms. Again, I would start by drawing my little box and labeling it. Okay, this is my n, that's my number of the term. This is my result, what you get from the term. 1, 2, 3, 4. You put the number 1 in for n, so 2 to the first power minus 6 is negative 4. 2 to the second power minus 6 is 2. 2 to the third power minus 6. 2 times 2 times 2 is 8, minus 6 is 2. And 2 to the fourth power minus 6 is, what's that, 2, 4, 8, 16 minus half. Is that right? 2 times 2 is 4, times 2 is 8, times 2 is 16, minus 6 is 10. Congratulations, kids, you survived a lesson on sequences. And that's not easy to do this day after a Super Bowl or